In this lesson, we are going to learn about application of liquid pressure in hydraulics. So these are learner's outcome. You find that direction of liquid pressure is not only directed downwards, it is actually in all directions. It is because the liquid or fluid particles are free to move around, unlike solid. So thus is able to move sideways. Okay, what do we mean by that? You find that the liquid pressure can act down, and then after that over here, since there's an opening, the pressure also act sideways. So you find that at different holes, you find that the pressure is different. Okay, do you still remember that the deeper it is, the more higher pressure? So you find that it is actually exerting at the pressure at different level, and in its sideways you find that at the bottom is most, so the water squirts out more. And we can apply this concept to our advantage. Okay, how? Since liquid flows actually can overcome certain constraints that a solid has. For example, if you push this solid to the right at the end, and you find that you just move right. But once it reaches the end, it cannot move further if you continue to push it. But however, for liquid, it can do what solid can't. If you push the liquid to the right, you find that the liquid will flow and of course move up. So the force direction in this case has changed from rightwards to upwards. So or you can see that the force is applied along the pipe direction. So if your direction of pipe actually goes this way, of course the force will be going downwards, or even if it is reverse, so you find that the force will actually goes in this way. So that's what is meant by force is applied along the pipe direction. Extending this idea, if we have a pipe that's filled with liquid, we can actually transmit the force in any direction that we like by exerting a force on this liquid. So if you have a U-shaped pipe, you can actually apply a downward force so that we can get an upward force. So if you go apply this way, you find that the liquid will rise. You may think that it's not amazing because a simple seesaw will actually do the same thing, because you apply a downward and you can apply this upwards. But however, using this liquid filled pipe, we can actually transmit the force over a longer distance actually as compared to let's say a seesaw. So you can actually extend the pipe, and you find that you can actually transmit the force over a long distance. Second thing is that you can also have multiple outlets and directions. So you can actually have different directions, or you can have another 3 different outlets. So once you push, this will also push, and this will also push. So in a certain sense, you get more flexibility. There's also another advantage of using such a system. You can actually increase or decrease the force that you apply. For example, you can apply 5 Newton of force on one end of the pipe, and yet you can get 50 Newton on the other end. How is it possible? It is possible through transmission of the liquid pressure, and because liquid is considered to be an incompressible item. Okay, this is known as the system, what we call a hydraulic system. So how does it work? In such a system, the liquid pressure in the pipe is considered to be the same throughout for simplicity's sake. So the pressure over here and the pressure over here is the same. Okay, it's the same throughout. So what you need in order to increase the output force by 10 times, what you need to do is to actually increase the pipe size at the other end, meaning something like this. So instead of the same pipe size, you make the pipe larger. So in other words, increase, what do you mean by increase the pipe size, the diameter? It also means that the area that is in contact is actually larger by 10 times. So assuming that the cross-sectional area is just 0.2 and 2.0 on this end, okay, on this end respectively, we apply a force of 5 Newton at this end, so 5 Newton. So the pressure exerted over here can be calculated by force over area, and since we know the force, we know the area, the pressure exerted is equals to 25 Pascal. So we find that the pressure exerted is just 25 Pascal. Okay, so since the liquid pressure exerted in the same throughout the pipe is transmitted to the other end of the pipe. So over here, you find that it is 25 Pascal. It is transmitted over to the other side. This is also 25 Pascal. So and then if we look at the other side of the pipe, we also apply the pressure equals force over area, where the area over here is actually 2 meter cube square. Okay, so 25 equals to force over 2. Okay, so the pressure was 25, the area was 2. So by bringing this across, you find that the force exerted upwards is actually 50 Newton. So this was 10 times larger than the 5 Newton that was exerted down. So generally this is the overall schematic. So you apply a small force of 5 Newton over here, and yet you are actually able to lift up of a force of a much larger load of 50 Newton. So this is an advantage. So in general, you find that because pressure of one side is equal to the pressure on the other side, so we generally say that force over area of first one end is equal to force over area on the other end. By rearranging, you find that the force, you find that the force 1 over force 2 is equal to area 1 over area 2. What it means is that the ratio of the force and the ratio of the area is the same. So if you have a larger area, you have a larger force. Likewise, if you have a smaller area, you have a smaller force. Is there any disadvantage to this system where you get a large force out of a small force? Yes, there is. You need to exert that 5 Newton over a longer distance. And the 50 Newton force only moves by a short distance. So what is meant by if you press this down, this only moves up by a small distance. You have to move this large distance in order for you to move this small distance. And I hope that you notice that these two movements are the same actually. Okay, what it means is that because the liquid is incompressible, the volume that's actually being pushed down is equal to the volume that's pushed up. And the volume can be calculated by the cross-sectional area multiplied by the height that you move down. Okay, so this is the volume. So height 1 times area 1 equals to height 2 times the area 2, okay, on the other side. So this is height 2, this is area 2. So by rearranging, you find that A1 over A2 is equal to H2 over H1. What does it mean? It means that the ratio of the area and the ratio of height in this move is actually inversely related. And so if you use the previous example, the ratio of area is 0.2 over 2 equals to the height 2 over height 1. It means that actually this is 1 over 10, so we find that H2 is actually 10 times less than H1. So let's say if the height moved down is moved by 1 meter, you find that the rise is only 0.1 meter. So just a side, if you calculate the work done by the forces, work done by the downward force is 5 times 1 meter equals to 5 joules. And you calculate the work done by the upward force is actually 50 times, but it only moved by 0.1. It's also 5 joules. So actually the work done up and down is the same. And it is because there's a trade-off. What you exert a small force, even though you get a large force, is because you exert a small force over a long distance to get a large force that only moves a short distance. So that is actually a trade-off. But that is fine, okay, because in practical application, okay, what you need to do is actually if this is a car brake, you find that you apply a small force over a large distance, the force is transmitted over, and you just only need a short distance to push on the brake, okay, and then clamp on the wheels and then cause the friction to slow down. But what you need is a large force, okay, you only exert a small force to slow down a car. Okay, so that's all for now. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysics.wordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.